Good morning, good afternoon, good evening, and thank you so much for joining us. My name is Mark Harms, and I am the Director for Client Technical Solutions here at Award Solutions, and I want to welcome you to this webinar, Introduction to Kubernetes Orchestration. For those new to Award, thanks for trying us out. And for those who know us, welcome back. We are so glad that you are here. I have a few slides to share before we kick things off. This webinar is brought to you by Award Solutions, and we work with the world's best networks, and we serve a variety of clients across the ecosystem. We are the training partner to many organizations like GSMA and CCA. We are passionate about learning and helping our clients improve their skill sets. Whether on demand or live, our webinars allow you to experience our training in a bite-sized fashion. This webinar is part of a complimentary series of webinars titled 5G Enablers, and included sessions on network slicing and beamforming in 5G, in addition to this one on Kubernetes orchestration. Since we develop free webinars on a variety of topics regularly, we do want to ask you for a small favor for those of you that are attending. If you enjoy this session, please share these learning opportunities with others. Please stay connected with us and consider sharing our emails and LinkedIn posts to spread the message. Thank you. We've had the opportunity to make a tremendous impact on partnerships, improving knowledge and skill sets around the globe. We've trained over 100,000 people on LTE, almost 20,000 people on 5G, and over 25,000 on virtualization technologies, like this one, Kubernetes orchestration. We have data-driven courses on automation, machine learning, Python, and much more. Our courses are role-specific, they're KPI impacting, and we tend to work closely with our clients to tailor courses to their employees' needs and networks by including network design, network logs, etc. And so we encourage you to check out the many opportunities that we offer. At the end of this session, we'll offer a coupon code for you to use for an additional 20% off. And as you can tell, we are recording this webinar, and then we will place this online. You will receive an email with a slide deck and a link to the recording later this week or early next week. Now, it's my privilege to introduce my colleague and friend, Emad Qaddoura. He is a principal consultant at Award Solutions, and is just a fantastic subject matter expert with a great teaching ability and a passion for helping others. He holds 26 patents and has decades of experience in this space. As you can see, over 30 years in telco. He's been at Award Solutions for over 8. He is expert grade. We're lucky to have him today. And I'm grateful and thankful that Emad is leading this complimentary webinar today, and you are all in for quite a treat. With that, I'll hand it over to Emad.
Hello, good morning, good afternoon, good evening, everyone. I welcome you today, and I'm really very excited to talk to you about the topic of Kubernetes orchestration. Thanks, Mark, for the intro. And the chat is available. I'll try to monitor the chat interactively as much as possible, and maybe entertain some questions at that time. Also, we'll leave a few more minutes at the end of the webinar to go ahead and take any questions that you may have. So, it's really kind of very important to understand the history. And so if you look at Kubernetes, it's not really, look at it, it's really was released in 2014, and it is an initial design by Google. The project started 2013, and now it's being sponsored by the Cloud Native Foundation, which is a project inside the Linux Foundation. I've listed here the co-creators in case you like to follow them and see what they're doing in related areas of technology as FYI. So history is important. So why now? It's been there for so many years, as you can see, and why all of a sudden now? Because things are changing. We used to have our applications in a huge monolith way, and that is changing to what we now know and well aware of is called microservices. So these large applications that used to have custom hardware are moving away from that and going into microservices, where we broke the application into smaller pieces that are independent, and all communication among these microservices is accomplished using APIs. And in most cases, it uses REST APIs. In the transition, of course, we remember we've seen VMs as a way to break or virtualize legacy applications. And now these microservices are going into to be virtualized inside containers. And so why microservices are important? I look at microservices as a huge enabler for going into this domain of Kubernetes and very, very easy to maintain and upgrade and deploy applications. So microservices basically are loosely coupled. So basically they have no dependency on each other. So if you look at these applications here, they can run independent. They're developed independently, and they actually can be done in different languages. Like this guy can be developed using Python, while this guy may be developed using Java or other languages. Where if we look at the legacy applications, in most cases, it is done using one specific language. So that enables me to bring applications that are loosely coupled, small. So the more they get independent, the smaller they are in size. What's the advantage? The advantage here becomes that I can easily deploy these applications. I can upgrade a subcomponent. So if we look back in here, I can upgrade the log transmit app or microservice without having to worry about upgrading the other components around it. And so the other thing is, it's really critical that these applications are using APIs. So microservices, one of the requirements to enable microservice to happen is to use APIs. So now we're talking about Kubernetes and Kubernetes orchestration, but as you see, the technology has evolved from this legacy models applications to microservices that really enables us to use Kubernetes. So these are like core foundations and core aspects of Kubernetes that must happen before I can really orchestrate at the level that I really desire. The other enabler to get us to have a successful Kubernetes orchestration and orchestrations at a smaller pieces is something called cloud native applications. So as we develop applications, as we develop these cloud microservices, we really have to understand that these guys are going to sit in a cloud. So a cloud native application is really critical. It's a lightweight function that's cloud agnostic, meaning, do you want to deploy it on this public cloud or that public cloud? Do you want to have it run inside on a Linux box that is basically based on a canonical, Red Hat, whatever? It really doesn't matter. And the beauty is, what if I've been there for a long, long time, upgrades and enhancing the capacity of an application was not something that's simple that you can do in a very easy fashion. But now I can do this in real time. I can scale an application, okay? I can have this application grow as much as I need, and I can make it come down in size as much as I need based on the demand. And again, the cloud native must be, applications are loosely coupled. So things have happened in the industry that enabled us to get to that level of ability to be able to make our networks really easy to manage and easy to deploy and easy. And when I say easy, it doesn't really mean straight easy, but it gets much easier. Now, the real topic is our Kubernetes. Okay, so why Kubernetes? So as you see, these additional technologies have come in place and have really evolved to a level where we are able to utilize Kubernetes. As you see, Kubernetes is 2014 technology, but now all the different technologies like cloud has evolved, applications and how we split application to microservices have evolved, and the technology is right to apply in many domains, like for example, telco. Okay, so why Kubernetes? Kubernetes is a project, like I said, it's an open source project that is the most common orchestrator for containers. So I can push containers in the network, in the cloud, in my network. What's so beautiful about it, I can even have applications deployed across multi-clouds. Those can be my private cloud. It can be multiple public clouds, and in addition to my private cloud. So the concept of hybrid cloud has become so much easier because think about it. Sometimes you need to scale, and your private cloud doesn't have enough resources to scale, so you may scale out to a public cloud. Or for geographical reasons and where your customers are located, it may be easier just to use a public cloud in some cases and a private cloud in other cases. So Kubernetes is capable of doing that. So the other thing that has really taken off with Kubernetes and deploying application is the ability to deploy on bare metal environment where things can be much less in overhead. So I don't have to carry on a lot of overhead in my host to be able to run my application. So bare metal environment is taken off quite a bit for deploying containers. And the other thing is scaling, like I talked earlier. Sometimes like there's an activity in the area and I need to have tenfold the capacity to be able to manage that activity and provide a reliable network. So I can scale in an automated fashion. I can set some threshold and metrics when and how I want my application to scale. And I can do that in an automated fashion, of course. The other thing that Kubernetes provides, it's as it deploys its containers in its way of deploying it, which we'll talk about here coming up soon, it does actually have a self-healing component. So it keeps monitoring its workloads across the multi-nodes and more beautifully across the multi-clouds. And it does have the capability of self-healing. It has a built-in load balancing. And in some cases, that may be sufficient for certain applications, or you can provide your own load balancer. And the other thing is that's really important is rolling updates. It has the capability to do rolling updates to where there is no downtime to your service. And one of the questions I see here is, what is a web scale? So Kubernetes come along sometimes with the terminology of web scale. Web scale basically it is a form of cloud deployment that is hardware independent, that enables me to deploy without having custom hardware. I deploy microservices and I enable all these flexibilities that come with Kubernetes. And Kubernetes, like I said, is one of the solutions, but is not the most common. Okay. Now, this is really where the rubber meets the road. What is the architecture of Kubernetes? And to a lot of us who have had many years in the industry, we do the things that are accomplished by this architecture day to day. So this is just a different twist. It's probably a more exciting and nicer twist, how we can deploy our applications and maintain them and have a reliable capacity, reliability, and sustainability of applications for providing a really top-notch service. So Kubernetes basically is split into some what we call a master node or nodes for redundancy and worker nodes. So if you look at the worker nodes, this is where I have my workloads, my apps. And the master node job is to look at, you kind of want to push an application to the network or to your cloud, and the master node will take care of how to place this application on a worker node. So it has, of course, what we call control applications. So this is, you can think of the master node as the controller for Kubernetes. And so some of these controller components also reside on the worker nodes, like what we call the kubelet and the kubeproxy. So I'm going to go here through through those components here in a bit more detail. So if one of the questions say, what do we mean by healing? So self-healing, basically, what happens is Kubernetes, if it has applications running here, Kubernetes is monitoring those application holders, I would say for now, until we talk about pods. And it's keeping track of the life of these pods. It's keeping track also of the life of the worker nodes. And if it sees something that is failing, it will make sure to give you the proper redundancy that you've initially requested. So if an application fails here, it will find a way to spin off another copy of this application somewhere else on a different worker node, maybe, or maybe on the same one. Okay. Now, the scheduler is kind of when I push an application to deploy on a Kubernetes cloud. The scheduler basically is the entity that keeps track of the worker node's workload. And it decides that I'm going to push this one on worker node 1 based on how the load is being distributed, based on the requirements for your application, because some of your application may require certain characteristics that it needs to be deployed at. So basically, the scheduler will communicate with a kubelet. And kubelet is the agent. It's like my agent sitting on that worker node that will make sure my application will get instantiated. Okay? So when I say instantiated, basically it will be responsible for creating the container that will host the application and the pod. And now I need to switch slides and come back to the slide as I'm going through. So what is a pod? A pod basically is the least or the smallest basic unit that does exist or Kubernetes deals with. So applications are deployed inside a pod, and these my network functions or my apps, depending on what technology you're working on, basically it's my software that I need to run and manage using Kubernetes. So what Kubernetes will do, will decide using the schedule which worker node it decides to run this on, and then the kubelet is responsible for getting the pod, which is basically just a wrapper that Kubernetes uses to manage that workload. And then it'll create the container that will host my application. So that's what kubelet does on the worker node. And that communication is all happening using APIs. So Kubernetes is based on all of its entities communicating using APIs. Now, once I get the application running, there is also other entities involved to make sure I have a healthy application. Yes, the scheduler decides which worker node, and there's the concept of controllers in Kubernetes. So what's a controller? It's just a piece of software that I tell it, hey, I need to deploy these applications. and scheduler decides where, and the controller worries about these applications that it needs to deploy. For example, we have multiple controllers that are part of the Kubernetes ecosystem. So we have something called a deployment controller. So once you decide you are going to deploy a deployment, the deployment controller is the one that makes sure that will happen. And it keeps track of the state of your pods. It will keep track of how your deployment health is. And we'll talk about self-healing. This is one aspect of self-healing that we mean. Okay, there are multiple aspects. And then there are other controllers like monitor the node. How is the node doing that is holding my workload? Then I deploy a work node that needs replication, maybe 3 times replication, maybe 6 times replication. So there is another controller. So this is all part of the controller domain or ecosystem by Kubernetes. So there is a replica set controller or a replication controller. This is kind of now considered old. And the replica set controller basically, when I deploy my application and I say I want a replica of 3, the replica set controller makes sure that I always have 3 running. So if one copy of it fails, it's due to the application failure, it's due to the pod failure, it's due to the node failure. The replica set makes sure I have my 3 running all the time. Okay, and there are other controllers that are part of Kubernetes. For example, as you may deploy things for different tenants on your cloud, you may have to provide some account per tenant, for example. And you have to provide all the communication among the different Kubernetes components is managed using secured using tokens. So it's also there's a controller that makes sure tokens are created. For some of you guys who've used OpenStack to manage and orchestrate virtual machines, you know that there are tokens being used for communication among the OpenStack components. This is not any different, very similar. Okay. Now here's also the beauty is I can have also what we call cloud controller manager. Now I need to integrate my Kubernetes from my private cloud. For example, I have a private cloud that has some workload for me, but also I need to push something into a public cloud. So those are all managed by Kubernetes, which is in short referred to as K8s. So the cloud controller manager is the entity in Kubernetes that will use APIs to communicate with the public cloud management system or control system. For example, you may be using a load balancer from the public cloud. So this is how the Kubernetes will communicate with the public cloud using this one of their cloud controller manager. So there are multiple cloud controllers and the manager keeps track of them. Okay, going back here. So I have a question said node is typically a host machine where one or more apps, VM containers are running, and that is correct. A node, basically a worker node, will host, like now we talked earlier, that pods are the basic organizational unit in Kubernetes, which will hold your containers, which will hold your applications. So the worker node is basically, yes, typically that is a host that will host my workload. Okay. That's a good question. Thank you. And now, so we talked about the scheduler, controller manager, kubelets. Now there is as I deploy applications and pods that host my applications and containers, I need some connectivity. I need some network. So what would I use to help me in the basic context in making sure that network is built properly, that applications are not all communicating when they're not supposed to. There's gotta be some isolation done. So that's pushed through the proxy agent on the worker node. Okay. Finally, then I need to store what I'm doing. When I spin off a pod, so this is a pod. When I spin off a pod, when I spin off a container, and then the application side, everything is kept track of in a database. And that is by default the etcd database. That's a persistent database that where Kubernetes, as it's creating components here, basically it's creating objects. And all its objects are kept track of into this database. Okay? Now, going further, so a Kubernetes cluster, just right on with the next question. So the cluster typically can have at least one master node and one worker node. And you can have multiple clusters. So you can have an X number of clusters as part of deployment. That's part of how you want to engineer your network. Depending on your workload, what they do, you may define certain cluster to do certain workloads and so on. Now, so a cluster, basically, if you have master node or multiples of master nodes for reliability and your worker nodes, this is the basic look of a cluster. Now you see here, one thing different than the next slide, that a pod here has multiple functions. And in this here, I have a pod that can have one or many functions, which means one or many containers. Now, this is like it's an engineering decision. The more applications I have inside the pod, the more dependence I create among these applications. Dependence can be by virtue, maybe how these containers may not be related to each other. So I may have to upgrade something, and by upgrading this number one guy, I'm forced to do something that impacts number two container. So it's really the recommendation in the industry is to run one application per pod, unless those applications are interrelated. That way, I can, if a pod dies, I only worry about that application, and I only worry about managing one application. I don't have a side effect that I don't need to have unnecessarily by having multiple applications in one pod. Okay? Now, so we talked about microservices, and we talked about also there is another attribute of microservices that they're stateless. Applications that have no memory. They don't remember. So stateless in general, the definition of stateless, if I have basically a client communicating with a server, I can request something from the server. Once I get my response, the server forgets about me. And stateless means if one application dies, the other one takes over without a problem. Or I can spin off, let's say this is one copy, second copy of the same application. Then I have another copy of this application here. So now what happens if this entity dies here? Am I going to lose any information about its job and what it's doing? And by design, if you design microservices, and in most cases, there are some cases where you have state. In most cases, they should be stateless. by virtue that it enables me to I store my information on external storage. That is persistent storage that's shared among pods. So that way, if this copy of the application dies, this other copy that Kubernetes replica set controller will create, because it's monitoring the health of these pods, then it will basically take over and continue the work without any impact. So Kubernetes by default provides what we call ephemeral temporary transient storage. Okay, so this storage is available for the lifetime of the pod. But if the pod dies, because that happens, if the pod has an impact where it just goes away, for one reason or another, there's a failure, then anything in its ephemeral storage is lost, which means my application maybe was, if I rely on this storage and not on an external persistent storage, that my application will be impacted. Okay. Now, here is another beauty of Kubernetes. We talked about Kubernetes being able to do things across multi-clouds. Now, how about containers? What container platforms do I want? I may not like Docker. I may like Rocket. I may like different forms of containers. So Kubernetes doesn't really care. Yes, the most common and the most frequently used is Docker as the runtime engine for the container runtime engine for running these containers in my pods. But at the same time, the industry has created what is called here CRI, Container Runtime Interface. If the container runtime engine obeys to the philosophy that's defined in CRI and certifies that I am CRI compliant, then it doesn't matter what container runtime engine I use. This is kind of nice because I'm not tied to Docker, I'm not tied to Rocket, I'm not tied to any specific container deployment. If something comes new and it fits the paradigm of CRI, then I can just use that. Okay. So as we talked earlier, kubelet is the entity that will create the pods and create the containers that will hold my application. So there is a certain interface that's defined according to this container runtime interface. If you're using Kubernetes, all these things happen for you under the hood. This is more of just making sure we understand some of that. Okay, so I have a question, explain more about Docker. Maybe I need a bit more information, what specifics, if you just add it to the chat. So another question here about, if we look at master node and worker node, are they the same or not? And the answer is really straightforward. In production environment, typically you have your master node or multiple master nodes that work in harmony with each other to provide you the reliability. And then the worker nodes are part of the nodes in your cloud. So these are hosts that are just used as part of the Kubernetes workload, where Kubernetes will deploy workload. There is a copy of Kubernetes that is open source, that is what they call all-in-one. All-in-one. So that's available, that you can get out there. It's OKD. If you search for OKD and Kubernetes, you should be able to find different ways of installing this. It's really straightforward of installing this and running a Kubernetes all-in-one, which means the master node and the worker nodes are part of the OKD also has something that's called OpenShift, which sit on top of Kubernetes, utilizes Kubernetes. But if you only want Kubernetes by itself, there is something called also Minikube. Okay, Minikube is an all-in-one that has both. Okay.
Emad, if you, I can summarize few questions, if you're okay.
Yes, please go ahead.
So one question from Manish was, is Kubernetes cluster is one master node and many worker node? How the controller fits in the cluster? That was one question.
So Kubernetes, excellent question. Thank you, Nirav and Manish. So basically, the master node can be one or multiple master nodes for reliability. So those can be all part of the Kubernetes cluster. That's one deployment. How can I have multiple clusters? So I can have other worker nodes. So I can have worker nodes as part of a cluster. Cluster 1, cluster 2 that holds multiple worker nodes. Okay. So those will have the worker nodes in here.
Another question was, can pod be restarted without losing information?
Very, very good question. So restarting pods, if we go back and look at the storage thing here, ephemeral storage is there for the life of the pod. If the pod gets restarted, ephemeral storage for the pod is retained. If the pod fails, its ephemeral storage is gone.
Very good. Another question was, it seems like that's more the question I understand is Docker mandatory in Kubernetes?
Great question. So if you look at this slide, Docker is one of the container runtime engines. Are there other container runtime engines? The answer is yes. So one of them is RKT or Rocket, like CoreOS, which is, I believe, now is part of Red Hat. Now, do I need to run Docker always as my container runtime engine? No. I can select multiple, any form factor of a container runtime engine, as long as that CRE implements the CRI interface to talk to Kubernetes.
Well, thank you. One last question, Emad, is how are various clusters controlled?
By the master nodes. The master nodes is basically the brain of Kubernetes. This master node is really the brain. So it is knows you can have, if you look at it, for example, we talked about I can deploy these worker nodes, this work. So I have a master node and some worker nodes, cluster 1 on public cloud 1. And I can have worker node cluster 2 on my private cloud. So all of these clusters are managed using my master nodes. So Kubernetes keeps track of this. Is part of the administration when you deploy and define your worker nodes and cluster boundaries that the master node will be aware of. So another question here about what services does CRE provide to contained applications? Excellent question. So if we look at the contained applications, here is basically a container that is running an application. So how is that container deployed and how I get a container running, application running inside the container? That's all managed by the CRE, which is in our case, when the most common one is Docker. Okay, so remember, Kubernetes utilizes those CREs. Kubernetes does not reinvent the wheel to do what the CRE does in terms of deploying a container and making sure that the container is running with the proper application in it. Okay. All right. I know we have about 19 minutes or so. I'm going to leave 5 minutes at the end for questions. Here is another interesting thing in Kubernetes. It's open source, and you can extend it in any way you want. So you can write your own controllers. You can enhance existing controllers to do something different. It's basically it's open path to what you want to enhance that may match your need. Again, this is done using something called custom resources. As we talked earlier, anything that inside Kubernetes, like pods, for example, we'll stick with pods, is a resource. And a resource has objects. Objects are stored in the ITSI database. Now, this is exactly what would you do. You create your own resource, which basically has its own objects, which has its own APIs, and that gets integrated with Kubernetes. So there is a room for you to enhance. And the beauty of everything is being done, as we know, in many avenues of the industry nowadays, using YAML files. You can use JSON. YAML is more common, but everything is declarative. Everything is done declaratively, very nicely. Okay. Now, a question about how can I access the replay of the session? I will announce at the end. You'll be able to obtain a copy of the slides and the recording. I'll explain that a bit more. Here is another really very interesting feature of Kubernetes. So if we look at legacy, now legacy for us in most cases maybe was running workload inside a VM. So my VM has some applications. And now with K8 or Kubernetes, I'm going to run things inside here's my app, inside the container, inside the pod. Because this is, again, the smallest unit that Kubernetes deal with. How is there a way where can I make Kubernetes really manage my VMs and my pods, my containers? And Kubernetes has that feature. So the Kubernetes master node now can manage. So if I transition this from legacy to be managed by K8s, then Kubernetes will deal with this as a pod. So there is an entity, it's also open source, called KubeVirt that does allow you to manage VMs as pods. So now you have the same orchestration engine that enables you to manage VMs and containers. However, KubeVirt, up to as far as I know of today, does not support bare metal yet. I'm sure it's going to come anytime. Okay. All right. So going further to some deployment discussions. I felt it's really kind of nice to know the overall flow. What happens when I deploy a service that is made up of multiple containers into Kubernetes? So one way to do it using CLI, which is provided by the kube control to create a pod. So remember, we deploy things in pods, and then pods hold containers, and containers hold applications. As you see here, all communication will happen using an API server. So the request comes into the API server, hey, create this pod for me. So the request will go, first, we will create an object to track this pod into the database. As you see here, there are many transactions to the database, and this is a persistent storage. And then the scheduler will be informed, hey, you have this pod that requires X amount of resources. These are the characteristics of this pod that needs to be deployed. So the scheduler knows its worker node's load and assigns or binds a certain node to a pod. The scheduler now needs to let his agent know. He has an agent running on worker nodes. He will communicate with kubelets, and kubelets will then create the pods and the containers. How? By communicating with the CRE. In this case, I'm using Docker because it's the most common. Okay? Once that has been accomplished, then we will update the state of the container, which, as you see, basically what it does, the API server is the mechanism to go and update the information to the database. Okay, so it's really a simple flow. It's easy to trace if you're running some kind of tracing mechanism, like if you're using Wireshark, you just have to know what to filter on. Okay, so here's a deployment example. So when I create pods, again, it's created by one of the controllers, which is a deployment controller. I'm going to create a deployment here that may have multiple applications. So we will make sure that my applications are hosted in containers when the container is hosted inside a pod. So I can have as many pods as this application deployment requires. And then again, like we talked about earlier, the scheduler will be responsible for making sure those pod placements in the proper node based on the needs of the application that I received in deployment YAML files. Okay? So question about security. Kubernetes does provide some security mechanism. I'll go down to that here in a sec. So there are some security mechanisms in Kubernetes. So sorry for the jump, but just to address the question properly. So it does have basic role-based authorization. So I'm a user, you're a user. What can I do within the Kubernetes deployment? And it can restrict containers from accessing resources at the host. So that isolation is really important, that we don't want the container with a malfunction and effect to kind of get everything on that host. And can also restrict images from approved sources. Beyond that, it's a cloud, it's a deployment. So you need to be able to take care of that security in other ways, firewalls, proxies, and what have you. Okay, good question. Now, if we go further here, if we look at deployment file, how I define my deployment, here is a sample YAML file. This is in YAML. Okay, again, you can do JSON, but YAML is more common. And you define what kind of YAML file, what is it doing? It's of kind deployment. And you specify in there how many replicas, for example. Some of these fields are optional. And some of these are, you have to have some minimum set. So inside the pod need 3 replicas. And by the way, my containers spec this is what I'm going to name my container. Here is what the image is. I can say, go get it pull it from a repo, that a secure repo, or if it's not present, because I may have a local copy, or I can change that policy. So there are multiple, and what port this container will be listening on. Because one thing that's really important, if you have a pod and you have a container, so this guy is basically, we said a lot of the applications now use REST API. So this port is the container, internal container listening port on. Okay. So replica set again makes sure that I have the right replicas for the application that has been defined. So if I have 3 here, I will always make sure I have the 3 running. If anyone dies, it will make sure that a new replica is created. Okay, so what's a service? Because typically you hear the term, oh, Kubernetes basically deploys my service. So a service basically is just a set of pods. So I have multiple containers running different functions, same function, that's all depending on what you're deploying, but basically a group of pods can make up a service. Okay. Now, just a recap on some of the main features in Kubernetes. Kubernetes is much more beyond what you see here, but I thought to just gather the things that are most important. Health process. Somebody asked about how do I know how to do health self-healing? So self-healing is one of the areas where Kubernetes keep monitoring its workload, monitoring its nodes. And also there is another thing in Kubernetes that's called probes. So probes are used, for example, when you spin off a new pod that has containers, when do I start communicating? When do I push in some initialization that is required? So there is a startup probe. When the application completes startup, that then I need to do some certain things. Okay. Readiness probe, when is the container is ready to receive applications? And by the way, you can customize those things. There are default actions that Kubernetes will do, but every application need is different. So you can customize those yourself. And the liveness. When do I need to restart or kill this application or this container because there's something? I can do scaling, again, on demand in an automated fashion, or I can do it manually. I also worry about making sure communication is happening pod to pod, container to container, and so on. We talked about the security and storage. There are multiple factors, and the beauty of it, I can plug in many types of storage. Like if I deploy it in certain public cloud, I can have a plugin that enables me to use that cloud provider's storage. It basically has a lot of flexibility. Okay, I know there are a lot of questions, and it's hard to handle all of them. I'll leave here a few minutes for you guys in case you're interested in some of the additional training we offer. That's we have this coupon code. You're welcome to scan your phone and scan this barcode. This is available until November 10th, or you can use the coupon code webinar at checkout to get 20% off. We have a lot of sessions and classes that are related to different technologies, virtualization, Kubernetes, containers, automation, machine learning, and AI, and many, many more. You're welcome to look at the Award Solutions website. And if you want to stay informed, I'll be more than happy to engage with you. We'd love to have you guys follow us and benefit from the additional stuff that's coming up as free webinars also, and be aware of what's going on. This is the barcode. If you're welcome to scan it and stay informed of what we do. And we're always trying to make sure we are keeping the flow going for the related latest technology. If you need to communicate with me and connect, here is the barcode for my LinkedIn. I welcome all the connections and be happy to engage there. Okay, so I'll try to take a few questions here. Oh, this
Emad,
is hard.
also, if you can write your email address.
Yeah, it should be part of the, okay. I will write my email address. It's easy. It's probably the only Q you'll see followed by an A. E, and then my last name. Okay, let me just copy paste it from somewhere here before we end into the chat. That'll be easier. Can you copy it for me, Nirav?
Yes, yes, yes.
Yeah, so what I have mentioned here is really the starting point. This is not a small orchestration system. Kubernetes, again, is an open source project. It is extremely rich of features. You'll be just amazed. Okay. Anyway, so let me see if I can say, when you say multi-cloud, then it can be between public and private cloud. Absolutely. It's the concept of hybrid cloud is supported by Kubernetes. So you can have the same Kubernetes masters responsible for monitoring and deploying things into private and public cloud. So what is the difference between a basic K8 cluster and a pod? A pod, very good question. So let me go back, try to write in here. So if you look at a worker node, basically when Kubernetes deploy application, it creates a pod. Basically, a pod base is a software wrapper around the container that will host my application. So a worker node, I can have multiple worker nodes doing something similar, and those together can be a cluster. Okay? So that's what it is. Security we talked about. There are tokens that for API communication, but if in the case where you need additional security, think about any private network you create. You need to create some kind of private network security, a cloud-based security, your VPN-like. So it does require you to do additional things. Okay. Okay, so I know there are a lot of questions here.
There was one question on does pod gets an IP or container gets an IP?
So how do containers in a different pod, in different pods communicate? Do we need IP pod ports? Absolutely. So there are a lot of details on the network part. Let me scroll back to some of the charts. So a pod by default, and that can be changed. A pod gets an IP address, and these containers here has ports. So this guy has port 1, and this guy has port 2. So this IP address is shared by the two containers. Now, there is additional work that needs to happen to expose these application ports to the outside world. These guys can communicate with each other using the ports, but I can go ahead and make sure I can assign a public IP address to the pod. I can assign, or I can do something similar to what you do with NATing, where an external visible proxy IP address can be mapped. So typically, what they do is place some kind of reverse proxy at the front of the different workloads in here. All right, I know there are a lot of interesting questions. Please, again, if you want to continue and dialogue, you can follow us again on a Word Solution on LinkedIn. connect with me. I'll be more than happy to engage and take on more questions to the best of my ability. I thank you for your time. I greatly appreciate your time, and I hope you have benefited from the session. And we will have the recording and a copy of the PDF for the slides in the next day or two. You'll get an email. I know there was a question about you'll get an email of that information. Promise you it will happen. And with that, I wish you guys happy and safe time wherever you are. And best wishes, and thank you for your precious time today. I really appreciate it.